Fifth day in chapter 4. Now we're trying to use these Riemann sums, which will give us an area under a curve. We're not going to be able to come up with this exact area, but we're trying to estimate it. So give you a little example here. Let's make a picture. So if I am doing, let's make that a little bit bigger, f of x equals x squared plus 1. And we're looking over the interval between 0 and 2. So here's x equals 0, and there's roughly x equals 2. And I'm going to make this parabola be kind of pronounced. This parabola looks, let's call it something like that. We know it's a parabola. It's opening upward. I've got this thing kind of spread out. I know it's not drawn to scale, but we're going to use this to figure it out. It says we're supposed to try to use 4 rectangles. So the first thing I need to know is, if we're using the interval from 0 to 2, how wide is each rectangle? What is my change in x going to be? So I've got an interval that's 2 units wide, divided by 4 equal rectangles. That's going to tell me each rectangle is a half a unit wide. So if I come over here and I say there's x equals 2, well, if I use those 2 blue marks, there's 2 rectangles. Well, there would be 4 rectangles. So 1/2, 1, 3/2, and 2 would be the x values that would denote the difference in each rectangle. So let's say that I wanted to use the right sum, and we'll do this in green. The right sum, which means my first rectangle is going to be half a unit wide. So in order to find its area, I would do 1/2, because that's how wide it is, and I'd multiply it by its height. Well, how do I figure out its height? If I'm using the right sum, I go to the right side of that interval, and I say it's going to be that tall. How do I get that height? I would do f of 1/2, because 1/2 would be the right side, and that would be my rectangle. So it looks like it's going to be, this estimate's going to be a little bit too big. Plus my second rectangle. Again, half a unit wide. Go to the right side of it. How tall is it? It's about f of 1 units tall. Again, we're overestimating. Plus third rectangle. Half a unit wide. Go to the right side of it, which would be 3/2. That would dictate the height. 1/2 f of 3/2. And then last but not least, last rectangle. It's about 1/2 a unit wide. How tall is it? Looks like f of 2. So there's my right sum. So now I work through, I figure out what these values are. To save ourselves a little bit of time, I'm going to take a 1/2 out of each of these values, because every other one of those 4 terms has one. F of 1/2 plus f of 1 plus f of 3/2 plus f of 2. Now what do I do for this area? Well, let's see. 1/2, f of 1/2. Go to the original function. What's 1/2 squared? 1/4 plus 1. That's a 5/4. F of 1, 1 squared is 1 plus 1 is 2. F of 3/2, 3/2 squared is 9/4 plus 1 is 13/4. F of 2, 2 squared is 4 plus 1 is 5. Put all that together, cleaning up what's inside. This looks like it's going to be an 11.5 in there. Multiplied by 1/2 would give you a right sum of about 5 3/4, 5.75 square units. Now, what would be different if we chose to use the left sum instead? The only difference if we were going to use the left sum is, instead of using, let's see, my left sum would say make your rectangle. Now, how tall is that first rectangle? Instead of going to the right side of it, I'd go to the left side of it. So that left sum would start off with 1/2 times f of 0. And now we're going to be a little bit under. My second one would be 1/2 times f of 1/2, because this next one I would go to the second rectangle. Instead of going to the right side, I go to the left side, plus 1/2 times f of 1 plus 1/2 times f of 3/2. And my apologies for making such a mess, but that would be the only difference. And if you figured that out, we'd end up with 3.75 for that left sum, if you want to do it. The only difference that you'll notice is on the left sum, you're going to be using the 1/2 of f of 0, and on the right sum, you're going to be using the 1/2 of f of 2. The only difference between those two sums. So there's problem number 1 done 2 different ways. Now I want to contrast that with this problem number 2. In problem number 2, we've got a big difference. We're using 4 rectangles still, so that's the same thing. We've got an interval that says this time go from 0 to 8, but what's different this time is we're supposed to use the data given in the table. And notice it doesn't say anything about using 4 equal rectangles. It doesn't say equal, so I'm going to cross that out. It doesn't say it. So when we go to figure it out this time, whether we do the left sum or the right sum, let's say that this time, just to be different, we're going to do the left sum first. If we go to do the left sum, I'm going to start out by saying, well, how wide is each rectangle? I can't do a uniform change in x because if we took 8 minus 0 and divided, we don't have 4 equal rectangles. So there is no uniform change in x. I can't do that. So what I have to do is using the data in the table. Well, this first rectangle is how wide? It looks like it's 3 units wide. My second rectangle, it looks like it's 2 units wide because it goes from 3 to 5. My third rectangle, it looks like is 2 units wide. And my fourth rectangle, it looks like is 1 unit wide. So this time when we go to figure out our area, we would do, well, let's see, how wide is that first rectangle? It's 3. And if I'm going to use the left sum, I want to use the value on the left side of that rectangle, which would be f of 0. So 3 times f of 0 plus second rectangle. How wide is it? Well, it says it's 2 units wide. What would be the left side of that rectangle? It would be f of 3 plus third rectangle, 2 units wide, by f of 5 plus, last but not least, 1 unit wide by f of 7. And now, what is f of 0? Well, according to the chart, f of 0 is 4. So I have 3 times 4 plus 2 times f of 3, which is 1, plus 2 times f of 5, which is 12, plus f of 7, 1 times that, which is 14. Total all that up, and my left sum comes out to be 52 square units. If I wanted to do the same thing with my right sum, what would be different? If I wanted to do my right sum, well, what would be different? Well, my first rectangle would still be 3 units wide, but now instead of using f of 0, we would do f of 3 plus second rectangle still 2 units wide. This time, instead of using f of 3, we'd use f of 5 plus my third rectangle is 2 units wide by f of 7 plus my last one is 1 unit wide, and this time we'd be using f of 8. And how would that change things? Well, as I worked my values through, and it just occurred to me that that's kind of hard, that 5 is kind of hard to read. If we total all those values up, 3 times f of 3, so here we'd have 3 plus 24 plus 28 plus 18 would give me a total of 73 square units. So there would be the difference in doing both the left sum and the right sum in both examples.